Hello and welcome to this GCSE tutorial video on essentially what does the periodic table tell us about atomic structure. So last time round I was looking at the structure of the atom and what subatomic particles make up that atom. Now I drew a couple of examples, but how did I know how many of each subatomic particle to draw? Well, that's where the periodic table comes in. Whenever we look at an element on the periodic table, there's some information on that table about that atom. So if I was to look at the example that I started with last time round, which was hydrogen, okay, to look at its little box, okay, on our periodic table, okay, there's loads of different ways in which it would be written, but essentially it has two numbers, okay, one at the top, one at the bottom. Now these two numbers tell us an awful lot about the atom. So, well, what are these two numbers, what do they mean, and how are they useful? Okay, well, let's have a look. Now, for the purposes of my videos, I'm going to have what I call the bigger number on top. Now, it's a bit difficult when both of them are 1, okay, so I will show you another example, don't worry. Okay, but the number on top is going to be what we call the mass number. Okay, now, the number on the bottom is going to be called the atomic number. So, every element has two numbers associated with it, the mass number and the atomic number. Okay, well, what are these different numbers? So, the atomic number tells us, okay, the number of protons, okay, number of protons in the nucleus. Oh. So, essentially, the number of protons, okay. Well, what's the mass number? Well, the mass number, okay, that is the number of protons, but also the number of that second, or the second subatomic particle, okay, that we talked about, neutrons. Now, what you'll notice about both these numbers is both these numbers are associated with the subatomic particles that are found in the nucleus. They tell us nothing about the electrons. So, how do we know how many electrons there are? Now, the way in which we know this is because all atoms, okay, when something's an elemental atom, okay, it will have no overall charge. So if we think back to the last time round, we talked about the charges of these different subatomic particles. Protons have a positive charge. Neutrons have a negligible charge. So what we're interested in is we're interested in the number of protons. So for something to have overall neutral charge, the number of protons has got to equal the number of electrons. So the atomic number, okay, also gives us an indication to how many electrons there are. Now be careful with this, okay, what it doesn't mean is it doesn't mean the atomic number equals, okay, the number of electrons, okay, this is not true, okay, this is not true. Okay, what it does mean though is it tells us the number of protons, and if we have an atom, the number of electrons are equal. So then when I come to draw my atom of hydrogen, okay, in the centre I've got my 1 proton, and around the outside I've got my 1 electron. Okay, so I've got 1 proton in the nucleus, and I've got 1 electron circling around the outside in the shell. So that's hydrogen, but what about something a little bit more complicated? Okay, so let's look at a different example. Let's look at lithium. Okay, so lithium has a mass number of 7 and has an atomic number of 3. So what does this tell us about this atom? So what we literally just talked about, we now know that this is our atomic number, so this tells us, okay, how many protons there are. So there are 3 protons. What it also tells us is it tells us how many protons and neutrons there are. So 7 equals, okay, our protons plus our neutrons. So, if we're trying to work out how many neutrons we've got, we can simply do a little bit of substitution into this and apply some maths. So, if we take our number of protons, which is 3, okay, what we can think about is we've got 7 equals the number of protons, which is 3, okay, plus the number of neutrons. Okay, so if we're trying to work out, okay, how many neutrons we've got, we're just going to rearrange this. So we're going to have 7 minus 3 equals n. So therefore, our n equals 4. Okay, so what we know about our lithium, okay, is that our lithium has 4 neutrons. So now, when we come to draw it, okay, this is nice and easy because we just sit there and go, okay, well, we've got 3 protons, so 1, 2, 3 protons. Okay, then we've got some neutrons, and we've got 4 of those, so 1, 2, 3, 4. Okay, now we can double check that just to see if it equals the mass number, so we should have 7 in total, 1, 2, 3, 4, 5, 6, 7. Good. Okay, so we've got the correct total number. So now we need to draw in our electrons. Now this is where it gets a bit more difficult, okay, because we haven't yet talked about how to draw electronic configuration, okay, of our atoms. Now I am going to talk about this in the next video, but just for the moment you're going to have to trust me. There are 3 electrons, okay. However, remember I talked about there could be multiple shells? Well, our lithium, it has more than 1 shell, and in the next video I'll talk about why that is. Okay, but here we go. Here is our atom of lithium. Here's our nucleus with our 4 neutrons and 3 protons and our 3 electrons around the outside. Okay, so here's a couple of things that might catch you out. Let's say we've just got helium. Okay, now helium could be written in a number of different ways. Okay, we could write it like this, we could write it like this, or we could even write it like this. Okay, it all depends on what periodic table you're using. Now, here's my top tip. Okay, if you look at all of these, sometimes the numbers are swapped around. Okay, the big number, so whichever number is bigger, okay, the big number is always the mass number. So, if you're ever thinking about, okay, well, which number's which, okay, the big number is always going to be the mass number. And sometimes in question, they might swap it round just to see if they can catch you out. Okay, it's not great, I know, but it's just something to be aware of. So that big number is the mass number. Okay, so how about you have a go? So I'm going to give you another element. I'm going to give you, let's go for calcium. Okay, so calcium has got a number 40 and a number 20. So what I'd like you to do is the main objectives from this video. So identify which of those 2 numbers is the mass number and the atomic number, and then I would just like you to identify how many of each subatomic particle there is. Don't worry about drawing it, because we haven't talked about how to draw electronic configuration yet. That's the next video. So pause the video, have a go, and then see if you've got it right. Okay, so let's see how you did. So these 2 numbers, which number's which? So this number up the top, the big number, okay, that is our mass number. The lower number here, the smaller number, this is our atomic number. So what about the different subatomic particles? So the atomic number, this tells me the number of protons. So therefore there are 20 protons. So remember we also talked about the fact that atoms are neutral, and because they're neutral they have the same number of electrons as they do protons. So therefore I have 20 electrons. Last but by no means least, the number of neutrons. How do we work that out? Well, we just simply take the atomic number from the mass number. Okay, so we have 40 minus 20. Okay, so that equals 20. So therefore we have 20 neutrons. So, hopefully, by the end of this video, what you're able to do is you're able to use the periodic table to identify the number of subatomic particles within an atom. By doing so, you should be able to identify what the mass number is and also what the atomic number is of an element. So, thank you very much for watching this video. In the next video, we're going to be talking a little bit about electronic configuration and how to draw those atoms in a little bit more detail. So, as always, thank you very much for watching, and I'll catch you in the next video.